Hi all, I'm Divya. I'm working as an assistant professor at the Department of Biomedical Engineering at Sri Sharma College of Engineering and Technology. Today, I would like to present the topic Thevenin's theorem. So, the circuit may consist of any number of resistances and sources that should be converted into a simple equivalent circuit which consists of a voltage source and in series with a resistance in it. So that is the Thevenin's equivalent circuit. So Leo Charles Thevenin is the founder of this Thevenin's theorem. And here, look at this complicated network. So this complicated network consists of two sources and three resistors. So this complicated network will be converted into a simple Thevenin's equivalent, so which is consisting of a voltage source and in series with it a resistance. And we have to add the load resistance. The load resistance is the resistance across which the voltage or the current flowing through the resistors will be calculated. And the next one, this is the statement of Thevenin's theorem. So Thevenin's theorem states that any two-terminal linear network having a number of voltage, current sources and resistances can be replaced by a simple equivalent circuit consisting of a single voltage source in series with a resistance, where the value of the voltage source is equal to the open circuit voltage across the two terminals of the network, and the resistance is equal to the equivalent resistance measured between the terminals with all the energy sources replaced by their internal resistance. We need to follow few steps to find out the Thevenin's equivalent circuit. So the first one is we have to remove the load and find the open circuit voltage. So the first in step one, we have to remove the load resistors. The load resistor means across which resistor we need to find out the voltage, or we need to find out the current flowing through that resistor. So that is the resistor we want to analyze. So that resistor can be identified as a load resistor. And next one is we have to remove the load from the circuit and creating an open circuit at those terminals. And we need to find out voltage across the open circuit terminals. That voltage is our Thevenin's voltage. So using standard circuit analysis techniques like Ohm's law, Kirchhoff's law or nodal analysis, we can find out the voltage across the open circuit. So the next one is we need to find out the Thevenin's resistance. So we have to go back to the original circuit and turn off all the independent sources. So replace the independent voltage source. If it is a voltage, we have to turn off all the independent sources, right? If it is a voltage source, we have to short circuit it with the wires. We have to remove the voltage source and short circuit the remaining terminals with the wires, and replace all the independent current sources with open circuits. So if it is a current source, you have to remove the current circuits and leave it as an open terminals. And you have to find out the equivalent resistance of the circuit as seen from the terminals where the load was originally connected. So you have to look at the circuit from the load resistance side. So this is your Thevenin's resistance. Now we found Thevenin's voltage and Thevenin's resistance. So now we can draw the Thevenin's equivalent circuit with the help of V Thevenin and R Thevenin. First we need to construct a new simplified circuit. So place a single voltage source. That voltage source value will be is equal to the Thevenin's voltage in series with a single resistor. So that resistor is the Thevenin's resistor. And now you can reconnect the load resistors to this equivalent circuit. Now, after connecting all the elements in the circuit, you can easily calculate the current through the resistor, load resistor, or voltage across it by using Ohm's law. So let's look at an example for Thevenin's theorem. So the given problem statement is find the current passing through the 24 ohm resistor due to the circuit. So we need to find out current passing through the 24 ohm resistor. So we need to analyze the 24 ohm resistor here. So this is considered as the load resistor. So first, before going into the Thevenin's theorem, we can verify whether the answer find out is right or not by using the normal mesh analysis. Using normal mesh analysis, we can find out current flowing through the 24 ohm resistance. And after applying the Thevenin's theorem, we can verify whether it is same or not. Here I have applied the normal mesh analysis. Here we have two meshes. So you have to apply the mesh analysis, two meshes, right? So two currents, we have to draw two mesh currents, I1 and I2. So if you are applying KVL to the first mesh, so there is a voltage source 10 volt. So 10 is equal to 2I1 minus 12I2. Sorry, 14I1. So here we have two resistors, 2 and 12. So 14I1 minus 12I2. And if you are applying mesh analysis to the second mesh, here we have minus 12I1 plus 36I2, which is equal to, here there is no voltage source, so you can write as 0 here. So by solving these two equations, you can get the value of I1 and I2. So I1 value is 1 amps and I2 value is 0.33 amps. We need current flowing through the 24 ohm resistor. So which mesh current is flowing through the 24 ohm resistor? I2. So I24 ohm is equal to I2, which is equal to 0.33 amps. So how can we find out voltage across the 24 ohm resistance by using Ohm's law? V is equal to I into R. So I value is 0.33 amps and R value is 24 amps. So if you multiply both these things, you will get the value of V24 ohm as 7.92 volt. Now we need to find out the Thevenin's we need to draw the Thevenin's circuit, right? So for that we need to remove the load resistor 24 ohm resistance and we need to find a voltage across this open circuit terminal. So you will get a circuit like this. If you disconnect the load resistor from the circuit, you will get a open circuit terminals like this. We need to find out voltage across the terminals A and B. So this is same as voltage across this 12 ohm resistor, right? So when the load resistor is disconnected, I will get a circuit like this. So if you find out voltage across, if you need to find out voltage across this 12 ohm resistor, so by applying the voltage division rule, you can find out voltage across this 12 ohm resistor. So what is our voltage division rule? So voltage division rule is total voltage into the resistance across which we need to find out the voltage. So the resistance across which we need to find out the voltage is 12 ohm resistors. 12 divided by the total resistance divided by the sum of the resistors. So total resistance is 2 plus 12, which is equal to 14. So that is equal to 8.57 volt. So the next one is we need to find out Thevenin's resistance. So we have to go back to the circuit. The thing is what we need to do is we have to remove the sources. So if it is a voltage source, you have to remove the voltage source and you have to short circuit the terminals with the help of a wire. So I have removed this voltage source and I have shorted the line. So if you shorted the line, So you need to look from this side. You have to look from this side. So if you look from this side, this 12 ohm and 2 ohm resistors have been connected in parallel. So if you need to find out this equivalent resistance, to 12 into 2 divided by 12 plus 2, which is equal to 1.71 ohm. So we have found the values of V Thevenin and R Thevenin. Now we need to draw the Thevenin's equivalent circuit. So V Thevenin is 8.57 volt and R Thevenin is 1.71 ohm and the load resistance is 24 ohm. So we need to make a Thevenin's equivalent circuit. So I 24 ohm is equal to I is equal. We need to find out current flowing through this 24 ohm resistance, right? So I is equal to V by R. So V value is 8.57 volt and R value is 24 plus 1.71. So which is equal to 0.33 amps. So if you need to find out V24 ohm, so that will be is equal to, so V is equal to I into R. So I value is 0.33 amps and R value is 24 ohm. So if you multiply both these things, you will get the value of V24 ohm. Thank you.